So good day to all of you. Today's lecture will be on post facto evaluation of coastal protection works, which is very vital in having the coastal developmental activities uh, that are in progress or that are being planned. The problem that hampers this development is the coastal erosion being suffered mainly by the coastal community due to coastal hazards, which is also dictated by the change in climate. So let's look into the coastal protection measures which we have in mind. We have enough in hand, but the problem is not the implementation. After the implementation, its performance characteristics is very important, which normally is being forgotten. And this is what I intend to bring in this topic. Coastal flooding is the one phenomena, and the other phenomena is the coastal erosion. Coastal erosion can be a perennial problem, and it need not have to depend on the extreme events, whereas the coastal flooding will always be controlled by extreme flooding. As I said earlier, we have enough number of coastal protection types of coastal protection measures which are widely known. In this lecture, what I am trying to do will be to share our experience along the Kerala coast, which is situated along the west coast of India. Presentation outline, brief introduction, impact of groin construction on adjoining shoreline. In addition, I'll also talk about the impacts of training walls in order to control sandbar formation near the confluence of estuaries and the open seas. Then I'll try to summarize my talk. Let's move on to Kerala coast for this exercise. The coast has 17 ports, one major port, and three intermediate ports, and it also has 44 rivers and 27 estuaries along its coast, and the length of the coast is of the order of about 600 kilometers. Over 65% of the entire coastline has been protected by seawall, which is a common structure till 2004. Soon after the 2004 tsunami attack, the entire coast was surveyed by us, and then we had given site-specific solutions, mostly involving construction of groin field. Prior to assessing the nature of the coast, the driving forces are very important, namely the wave characteristics, and which includes wave direction, wave height, and wave period. As you can see in this picture, this has been obtained, and then based on which we try to uh, evaluate the groin field, how it could perform using numerical modeling, and then we go into the site to implement the groin field. Prior to that, we have to assess the nature of the shoreline, how it can, what is the kind of erosion rate it is suffering. So for which we use the satellite data. The satellite data or the types of satellite data are this Landsat, which are shown given here, and we subject it to the image processing in order to assess the shoreline positions. Along the shoreline, we take about a number of transects depending on the kind of vulnerability it has, or depending on the nature of the suffering it has gone through. And we also fix up a baseline from which we try to find out what is the shoreline change. And then we use what is called as the EPR distance and LRR distance. But I will be covering mostly the EPR distance, which gives you the minimum requirement. This method needs at least two shorelines, as you can see here, and the distance between the shoreline and the time taken between the oldest and the most recent shoreline which you are interested in assessing the erosion rate. Once that is done, then we try to draw a line between here and the shoreline change, the rate at which the shoreline changes has been taken place. And then we try to fit a line based on which we know what is the kind of suffering it has undergone, which will finally facilitate us in arriving at the solution of the groin field. As I said earlier, Kerala has 9 coastal districts, and each of which has a number of locations. As you can see here, I am taking the Thiruvananthapuram district, and the district map is shown here, and the locations where we have concentrated are given here. So this helps the planners and the decision makers to decide on how to go about and also look at the budget available, etc. For example, here you see that there are locations like Puntura, Bhimapalli, Madan Villa, and then Chilakur. Madan Villa is for training wall. So when was it constructed? So that year is given here. What is the groin length? Of course, this you forget because this is training wall. When you look at the groin, I mean the eroding area, we have considered only 800 meters, for which we have provided 5 groins, transition groins. I would not go into the complete details of how to decide, etc. But then we use the basic thumb rule that the length of the groin should pierce the surf width, and the distance between any two adjoining groins should be less than 3 times the length of the groin, which is this is just a thumb rule. But then there are so many other things which you need to put in a lot of effort to find out how effective the groin field could perform based on its spacing between them. And also transition groin field is the one which can be quite handy, because otherwise if you are going to have all of same length, the downstream along the downdrift side you might face erosion. So then people will start claiming that this groin field is shifting the eroding area. So we have to be careful, and that's why we have gone in only for groin field. So having said that, now this is what we have done. Although we have used both EPR and LRR rates, methods, almost both have provided us similar results. And this picture shows that this green lines shows that so much of accretion is taking place, and there are some pockets where you have erosion taking place. That is after the construction of your groin field, after the implementation of the groin field, for example for Puntura groins. This looks quite quite good, because you see that most of the stretch has resulted in accumulation of, I mean, the advancement of the shoreline or the beach with the enhancement. So like this we have done for all the 9 districts. Due to time limit, I am not going to cover each one of them. Then we move on to yet another location slightly north of Trivandrum, which is Kollam. Kollam district is of length of about 45 kilometers, and the areas we have identified. This, of course, the field engineers have supported a lot with their information. So what we have done is we have visited the site and we have implemented the grind field. And the details are, when did we construct this, the year of construction are given here. The distance between the two locations are provided here, and the grind stretches are given here, how many number of grinds we have constructed. The length, the spacing, etc. are avoided here due to want of space. So this has already been constructed. So now what we are trying to understand is its performance characteristics. So here again we see both the methods of assessment of the shoreline changes after implementation of the grind field has yielded almost identical results, proving that the grind field has been quite effective. If you want to check this, you please have to visit the Google Earth and see for yourself to believe all these things. So as I said earlier, we have done this for all the 9 districts, 9 coastal districts, as you can see here. These are all the 9 districts. Only thing is I have just stopped with 7 districts, a few districts, 1, 2, 3, 4, 5, about 6 districts I have shown, or 5 districts I have shown, and each of the districts have some of these locations where all this entire stretch was affected by the tsunami and the entire coast was swept by the waves, and the seawall that was constructed long back has been completely disappeared. And now you see all these locations, each of these locations, how these two methods have performed is providing you the erosion accretion rate and the erosion rate. There are some small pockets where you still have some erosion to be completed, I mean to be taken into account, but it may not be so serious. But anyway, it gives you the performance characteristics of the grind field. So this being the case, the success of the grind field, let's move on to conserve the Kollam beach, which is again closer to this place, where you have a harbor here and you have the northerly drift is in this direction. So the predominant drift is moving from right to left. And in this case, what is happening? This beach formation is formed. It's a beautiful beach, but there are some erosion taking place here at this location. And some of these locations we have provided strong grind field, and we have had a good amount of beach formation. Naturally, at certain locations where you have protected two adjoining stretches, in between the two adjoining stretches, there can be some amount of erosion taking place, and that need to be uh, looked into carefully. So here we have an obstruction that is a long breakwater, and this breakwater also going to have the diffraction of waves taking place, and this is going to eat away the material around this location, which was anticipated, not, I would not say anticipated, but when we do the post-mortem, that is what we try to understand, the basic physics of the coastal engineering problem. So the transitional grind field was constructed in 21, not far away, not long back. So these are the two areas where the transitional groin field was done, which is quite good. And in between, we had proposed a groin field in between this, which was not constructed. Now there is a proposal that why not we have offshore submerged detached breakwaters. Both the purpose is same. It is to tame the waves as well as tame the longshore sediment transport and lead to advancement of the shoreline. But there are some inherent problems with submerged geotubes. In fact, construction of submerged structures is not so easy when compared to the groins, which are land-based construction. Not only that, maintenance also is going to be a bit of problematic. But then they wanted to proceed with a submerged breakwater, as you can see here, in order to, instead of the groin field which we had proposed for the two adjoining locations, already protected by groin field. So this is the structures which are superposed on the bathymetry, and you can also see the groins here. And this area has been suffering damage, as you can see in this on the left side. For this, we came up with a geotube submerged, over which will run a geotextile mattress with proper filter layer in order to avoid a scour taking place. But then this also has to be ensured, that is the lateral stability of the geotube. For that, we have proposed precast concrete reefs with perforations as a measure to minimize or completely avoid the lateral oscillation of the geotube. Not only that, this concrete reefs will also enhance the enhancement of biodiversity, and hence it would be. So this is the final concept which we had in mind, and this is yet to be implemented. This was the one which was published recently into August 23rd, 2024, where groins helped restore eroding beach states NGT, that is National Green Tribunal. This is a pictorial or a video clip which clearly shows the performance of the groin field. It is somewhere along the Tamil Nadu coast where I come from. So groin field, that doesn't mean that you can construct a groin field wherever you want, wherever erosion is taking place. You have to assess what is the reason behind the problem. This is an interesting area that is at the tip of Indian Peninsula. You see, they had constructed in the mid 70s, about 7 groins were constructed, but for mid 70s, during the 2004 tsunami, when we went, after two and a half decades, no beach has been formed. Simple reason is that there is no sediment transport taking place. So groin fill can be thought of only at locations where you have a long-shore sediment transport taking place, which can easily be assessed. So in this case, when we went for the tsunami, Tamil Nadu, the coast which was affected by the tsunami of 2004, the local people had expressed anxiety about the water coming inside and the sufferings they have faced, and they wanted some kind of a protection measure, and also so that it can also help their livelihood. So realizing this, because this is of not of any use, already constructed, but what we did is, one, this extreme groin we try to extend, as you can see here, about 400 meters we extended, and that resulted in a small harbor, and people are extremely happy with this kind of. So when you are dealing with coastal protection, you should also consider socio-economic aspects, which are very important. Now, having talked about the coastal protection measures mostly pertaining to groin fill, let's move on to draining walls. There are a number of rivers, as I said earlier, draining into the Arabian Sea. We looked at some of the important locations where the sandbar formation was posing a big problem, and they wanted us to give them a solution to at least minimize the sandbar formation, and all these things we have done, but then I don't want to go through all the pictures because it's going to take away my time. So I'm only presenting typical results. So this was the scenario in 2003 2013, where we just had two training walls. After that, we continuously monitored, and it has become more or less stabilized, and it is, as you can see in the picture even today. Yet another area where we had the Cheruvuttur. So the years are given here: 2004, 2010, 2017, and this is somewhere early of this, maybe 2020 or something like that. This is Korapura. So we see that the training wall was a great success, and whatever we have planned had come up into uh, has resulted in success. Now let's move on to one soft measure which is being discussed widely. This is somewhere here we wanted to install a geotube to protect the coast, where there's not much of sediment transport taking place. I mean, so mostly it is coastal flooding, and due to sweeping of the sand by the waves. So this is the status of the coast before it came to us. What we did is we completed a structure with three geotubes with UV stabilizer on top, extra UV stabilizer to take care of the deterioration due to ultraviolet rays. And then we had a strong uh, base, the toe, which is excavated toe and not an exposed toe. Exposed toe, we found that it was not so good, and because it can easily yield, and cover can penetrate, and the stability becomes questionable, and that is what we faced. And then finally we decided about an excavated toe, and you see that this is the only beach which is available for the coastal community, and hence we didn't want to use any kind of stones, and so we have and this area was filled up with this sand. So good, it was working fine, but then you have the vandalism coming into picture, the human intervention coming into picture, and also even during the construction, one has to be extremely careful. What are all the flaws here? We can just see filling up is very important. It has to be up to about 90% of the volume of the geotube, and when you have the overlapping, it's very important. This is a vulnerable location, because when you have coastal waters jumping, propagating into, the overtopping taking place, you can say that you can have the downwash. Downwash will remove this, and the instability will take place near the joint between any of the two geotubes. So this is very important. That is what we had. And vandalism, as you can see here, and this resulted in these are some of the issue with implementation of geotubes. Yet another area where we installed was somewhere here. Unfortunately, this dot has gone down. So it is somewhere here. This was also a success. This was quite a successful project, because what we wanted is, we didn't want the geotube to be exposed. So what we did is, we had also the gabion, as you can see here. This sustained for a decade, and later it yielded only, it resulted in some kind of a collapse because of people trying to tie their boats to the gabions. That is another issue. So this is how the a glimpse of the construction sequence. So you have the geotextile, geo tube, and over which we have the geo bags, and then you have the. So to summarize, the maintenance and the monitoring of the coastal protection measures is extremely crucial for several environmental, social, and economic reasons. The key reasons are, as which are very essential, are preventing coastal erosion, reducing flooding risk, particularly the coastal flooding risk, uh, protecting the biodiversity and ecosystem, supporting local economics, or enhancing the livelihood of the coastal community, adapting to climate change. That is a topic which is very, very important now these days, and safeguarding the infrastructure, and also for the future coastal development and safety, all the more important. So in conclusion, maintaining coastal protection measure is very, very essential. With this, I conclude my talk, and thanks for your kind attention. So also remember that plantations can be the one of the natural barriers for coastal protection, and which I am not covering in this video, and probably in the next sometime later I will do that. Thank you.